In this video, we're going to overview the very basics of how a sine wave and cosine wave work, and we're going to use the unit circle to do so. So I'm going to go ahead and just get straight into this. Here we go. First of all, we're going to graph the equations y equals sine x and y equals cosine x. But before we do so, we need to kind of have a sense of where those parameters are, what kinds of information is going to be inputted, and what kind of information is going to come out. So that's where I'm going to go to my unit circle. And I notice that what I'm inputting into any sine or cosine function is an angle. And when we graph these, we want to graph them in radians. There might be applications to graph them in degrees, but when you're talking about some of the physical applications and definitely pure math ones, we use radians to graph trigonometric functions. So if I look at the input, it's inputting an angle. It's going to be 0, and if I go all the way around the circle, it's to 2 pi, and there's all these sort of in-between points. And so I get a sense that everything in my input is in terms of pi. So instead of counting 1, 2, 3, 4 along that input, that x-axis, I'm going to count by these radian units. And in fact, if I do every single one, those don't quite fall in a direct order, meaning pi over 6 and then pi over 4. Those aren't spaced evenly apart. So I'm going to skip over pi over 6 and go straight to pi over 4 as my first point of input. And then if I go in that pattern, that was halfway, or 45 degrees if we're using degrees, then if I go in the same amount again, I'm up at the top at 90 degrees, or pi over 2. And what I'm going to notice is, okay, pi over 2, that's half a pi, which means that every 2 tick marks is half a pi. That means every 4 is a full pi. And now I don't really need to write everything out, so I just count 4 more. 1, 2, 3, 4, that would be 2 pi. Okay, and if I had 1, 1, 2, 3, 4, that would be 3 pi. And then the same thing over in the other direction. I got negative pi here, 1, 2, 3, 4, negative 2 pi, and negative 3 pi. Okay. Now what about the vertical direction? Well, what is the output? And what we had the last time is that on the unit circle, the sine of an angle is the y-coordinate. So we're going to look at these y-coordinates. The y-coordinate here is 0 at 0, and then it gets as high as 1 at pi over 2, or 90 degrees, and it gets as low as negative 1 at the bottom at 3 pi over 2, or 270 degrees. So my output is no less than negative 1, no higher than 1. So the top here, I'm going to put 1. And the bottom, I'm going to put negative 1. And I have nice half marks because I notice, oh, there's half that shows up a bunch. So maybe I want to be able to use that. So there we go. I've got set up my grid. And let me go ahead and plot. So what I'm going to do is I'm going to take the y-coordinate at all these places and plot it. So the y-coordinate, let me change colors here. I'm going to change to, let's go purple. The y-coordinate at 0, if I input 0 as my angle over in this section, it outputs the y-coordinate is 0. So I input 0, I get 0. 0, 0 is a dot. When I input pi over 4 up here, I get the square root of 2 over 2. Now, as a decimal, that's about 0.7. So it's it's roughly a little bit less than halfway between those 2 tick marks, between half and 1. And then we've got pi over 2 here, and so 0, 1. So 1 is the y-coordinate there for pi over 2, and so on. And what I'm going to notice, the next one here is going to be coming back down, and then back down to 0. And then it's going to be negative. If we look over here, go to pi, and we go another same amount to 5 pi over 4, we're at negative root 2 over 2. So now it's gone down roughly there, this one down to negative 1, and so on. And you'll notice very quickly that a pattern will start to emerge. And it actually goes the other direction as well. In fact, I don't even need to. I'm not even looking at the unit circle, because once I notice the pattern, this pattern continues as I rotate around. Because as you continue to rotate, you come back to the same point again and start that cycle all over again. And so on. Okay, now, while I'm sort of plotting these points out, The word that we use to describe this pattern is periodic. And periodic means a repetitive pattern. Okay. And then I'm going to do my best to try to draw a smooth curve between all these. And there we go. Okay, now there you go. There's a graph of y equals sine x using radians as our input, and our output obviously is just in real numbers. Now, what you'll notice that this waveform has a peak and a valley, and it has a distance before it repeats itself. And so we're going to talk about those two ideas. In the next video, we'll go into how to graph these ideas, but in this video, I'll introduce those ideas. So first, if I start here at the origin, let me choose a better color than that to highlight it, maybe red here. If I start at the origin, right there, and I measure the distance until that cycle restarts, it restarts over here at 2 pi. So the wave restarts there. That's the period. The period is the distance between when a cycle starts and when it restarts, and this distance is 2 pi. And then if I measure the distance from the peak down to the valley, okay, if I measure the distance between the peak and the valley and then cut that in half, I get what's the amplitude. In other words, the amplitude is actually halfway. So the amplitude is something that we define to actually come from something called the midline, which we'll get into more in a couple of weeks. So the amplitude here is 1. So the distance between the peak and the valley is not the amplitude. The amplitude we actually define to just be from the halfway point up. And there's a reason for this. A lot of these waves well, these sort of basic waves are symmetrical. And this is a good way of measuring how loud something's going to be as well and comparing it. So the amplitude is the distance from the halfway point, and the best way to do it sometimes is just to measure the distance between top and the peak and the valley and cut it in half. Okay. So here I have an amplitude of 1 and a period of 2 pi. Now let's see what happens if I do this same thing with cosine. Cosine on the unit circle is the x-coordinate. So if I plug in 0 for cosine for the angle, I don't get 0 like I did with sine. I get 1 because the x-coordinate at 0 is 1. So I end up getting a point up here at the top. When I plug in pi over 4, the next one over, I actually get the same value as sine, square root 2 over 2, or roughly 0.7. And then when I plug in pi over 2, the next one over, I get 0. So it comes down here, and then as I keep going, I'm going to notice a very similar pattern. It's going to be negative root 2 over 2, then down to negative 1, negative root 2 over 2, 0, and so on. So the difference with cosine is not that it doesn't actually have the same pattern. It has the same basic pattern. If you look at all the coordinate points around a unit circle, they repeat themselves in the same order, no matter if it's the y-coordinate or the x-coordinate. It's just about where you actually started in that circle and the values there. There we go. And I'm not going to complete this one all the way other than to just kind of get a sense here. And then I'm going to trace this best I can, just like the last one, so we can do some comparisons. Okay, now I'm going to do the same sort of measurement here. What happens if I take a measurement from the origin to where it restarts again? And I didn't mark these out, but this would be pi and 2 pi. Okay. And this top would be 1, and the bottom would be negative 1, just like in the sine graph above. All right, well, if I look at the distance between when it starts and restarts again, I get another period of 2 pi, which makes sense. It has the same pattern. And if I were to measure the distance from the valley up to the peak, and then cut that in half, so the halfway point there, I would also get an amplitude of 1. The difference between these two is where they start in the pattern. And if I want to sort of simplify it, and we're going to use this in the future, sine starts in the middle. And then as it moves to the right, it goes up. So its next step is to go up. So it starts in the middle and then goes up to its peak. Whereas cosine starts at its peak and then goes down to the middle. So that can actually be a great way to distinguish when you graph between sine and cosine. If you have the same basic set of rules in place, you can start with those rules, and then the only difference is where you start and where you go next. And we'll get into those nitty-gritties in a later video. But for this video, I just wanted you to see the sine wave, the cosine wave, what the definition of the period of the waveform and its amplitude are. And we'll get into more of those details on how to graph it when those things change in the next video.